This is the assignment submission for group 003 for stream processing subject for pilani data science 2019-2021 batch. This is the video submission for part 1 of the SPA assignment for group 003. We have 3 members, Sudipta, Savitri, and myself, Nikhil. I will be presenting our solution in this video for the group. The requirements, as stated by the assignment problem definition, is put up here. The basic idea is to build a Facebook-like private community app where users can create their own communities and add users to it and have each of those communities scale. It should the requirements state that we should support 2 major features: creating and sharing of posts. Posts means they also come with things like how many likes and dislikes and comments on the posts, along with direct messaging for users and groups. This, as is a stream processing subject, our focus is going to be mostly on the backend infrastructure and the data flow layer and the stream processing layer, rather than the front end. So the front end and the client side and the server side code that the client would interact with for the front end would all be assumed to be some kind of scalable design that's based on either Node.js or JavaScript or Python. Okay, so with that assumption, let's move to the basic architecture that we propose. The architecture, as you can see, is it consists of a client, which could be a mobile client, or it could be a desktop site that people log into. There would be a website server code, web server side code that would be, like I said, it would have to be designed in a distributed, scalable way, and it could be written in Node.js, JavaScript, Python, or Python Flask. And one of the important pieces of this is that any unstructured data that we get, like audio, video, and images that people want to share on their posts, this kind of messages, these kind of files would be separated at the website server of the server side code, and it would be sent off on its own process, and not exactly shown in this architecture diagram, but it's just mentioned over there, to a data lake or a content delivery network endpoint, and it just retrieves the link to wherever that would be, and sends that to the Kafka producer. The reason for this is that, of course, Kafka is not it wouldn't large files, audio files and video files could be large, and putting them into the Kafka cluster is not the most optimal way of using our Kafka cluster or serving the needs of what we want to achieve with this architecture. And so the burden would be on the web server code or the client to kind of resolve the link and have its own code to stream the data, to stream the video or the audio from whichever CDN or data lake we choose to employ, right? And The other thing is that this will write to a Kafka consumer. Sorry. Uh, so the website server code would actually communicate with Kafka using a consumer. Um, sorry. The website server code would write every message and post it gets to a Kafka producer, which would write to the Kafka cluster, and the website server code would also instantiate Kafka consumers depending on the user requests uh, and the user login actions. So or the Kafka producer and consumer basically they would be talking to the Kafka cluster, which would store all the post data and direct messaging data that comes in for the last, you know, 48 to 96 hours. Basically, the idea being that whatever the bare minimum amount of activity or data that you know a person would expect to see when he logs in on any given day would be would that amount of that window of data would be stored basically on the Kafka topics, and and those topics would serve as an in-memory store for user requests and to serve up the user community feeds. Um, Data will obviously be organized into multiple topics. There's more on that in further slides. Our stream processing layer, the analysis layer, is going to be using Kafka streams, because Kafka streams is they're gonna live on the same servers on the same nodes as the Kafka cluster as the topics it's themselves. There'll be less need to move data around to the stream to the analysis tier. Before we can do the analysis, since they both live on the same uh, distributed cluster, the Kafka streams can do local processing of the data in whichever topic uh, and whichever partition of the topic is being stored on the respective node in Kafka, right? And a second part of what the Kafka streams would be doing would be writing to persistent stores, writing the data to persistent storage. And yeah, so and depending on the kind of requests that the user might come up with for older data, they could the web server side code could potentially hit the Cassandra database directly. We also would be having Neo4j, are recommending that we use Neo4j as a graph database, because any community that we build, a large amount of information of information that we have in this kind of app would be the connections between different users and the communities and the posts and how they interact with each other. And so one of the best way to store this and analyze this information would be to store them as graphs. And since uh, these can scale to millions and millions of users, we suggest that we use Neo4j, which has an GPL license for people to use. Uh, and yeah, so we would store two kinds of data. Basically, we would store the same data directly as posts and direct messages and conversations in Cassandra, and we would also keep the related graph level information for all the users and posts in Neo4j. And along with this, I guess we would also have the store for either the CDN or the persistent data lake for all the unstructured data. Another part of this architecture would be visualization. So that would be the last piece, mostly for data analysis, data streaming analysis. So we could use Apache Superset, Grafana, or Kibana. Any of them would solve this. More to come in the further slides. Okay. So architecture, most of it I've already mentioned. right? You can see some of the details that I just spoke about in here. Um, okay, and moving on. Okay, so I want to talk about the life cycle of a record, whether it's a post or a direct message. We'll take the example of posts first, and then we can imagine similar kind of process for direct messages as well. Okay, so client, anytime a user comes in and creates a posts, the server side code would take the relevant information, separate out the audio, the unstructured data, send the unstructured data to CDN, replace that with a link, and send this information to a Kafka producer. The Kafka producer would write this to a common, receiving posts Kafka topic, which is kind of the trigger for all the kinesis for the Kafka streams, which would actually process the data. Data would not live in this common receiving posts for a long time. It would immediately be consumed by the Kafka streams, and it would be returned to Cassandra near 4j, and it would also be returned to user level topics, user level topic and common post topic. So and the user level topic is so, and while this is going on, the server side would have also created a Kafka consumer to read the user level um, community feed topic, and so this and this consumer basically would be able to read user level topics and produce. So the post that was created would move from the receiving post Kafka topic to the common uh, topics, common posts topic. And if there is, users who are related to the user who created the post through any of their connections that are there in Neo4j in the graph database that we've identified, based on that, and if there are user topics that, or if there are users active, at that point, who would like to see this post, in the Kafka stream would look up that relevant information from the graph database and uh, write it to the right topic inside Kafka, so that if that user has if the user is logged in, he would have a Kafka consumer that's been created by the server-side code, which would read that queue and they would be able to receive that topic. And the concept of sharing a topic is essentially to add it to their own street, to add it to their own stream community feed, basically. So that would be handled in a similar way as a user, as a new topic creation, but it would have an existing ID, so we would just have the new user who shared it also getting tagged to the same topic, and increasing the connections from there. So yeah, and all posts that have been made in the recent past, whatever is considered to be what we need for this for this system, as the active amount of feeds that people can expect to read and use, that amount of time is will be the expiry data, will be the expiry date for the messages in the Kafka topics, especially the common post topic. You can imagine that a direct post would have its own, similar common topic, and from which would initiate Kafka streams to write it to user level uh, direct messaging topics. And similarly, you can have Kafka consumers, which would be reading those user level topics to get the direct messages. Okay. So one of the other things is that I wanted to give a data perspective of what happens when a user logs in. Whenever a user logs in, the server-side code would create a message in a topic that would serve as a trigger for Kafka streams, which would essentially initialize Kafka topics for that specific user to consume. And the needs of this app means that we basically need to create two kinds of topics for every user, a feed of posts, which have been shared by their connections and their own posts in that feed, and also any direct messages that they might receive from other users who are online at the same time. So anytime a user logs in, the server-side code writes the user info to a user login topic, which then triggers a Kafka stream process to create the relevant new topics for each user, for the user who just logged in. And it would also kick off other Kafka streams process, which would start reading through all the messages in the common post topic, which contains data for the last 24 hours, for the last 48 hours approximately, and based on information in the graph database in terms of connections, all relevant posts that are present in the common posts would get pushed into the user level queue, user level topic that's created for the user. Right? And while this is happening, the server-side code would have created a Kafka consumer for that expected topic, and it would start reading that. So as soon as the Kafka streams is able to, on the server side, start pushing posts from the common post queue into the user level posts, the user on the other end would be already receiving those queues because the Kafka consumer is set up. And any user level topics that we create are going to be short-lived, something around like 4 hours after the last consumer reads the topic. The topic and the message itself would expire. This is just a list of all the topics that main important Kafka topics that would serve as our architecture. Is that you have a common post receiving topic, so any post information, comments, likes, all that stuff would be coming into this common post receiving topic, and anything that comes in here gets processed by Kafka streams and put into the relevant databases and topics with the updated information. Common direct messaging topic serves a similar purpose but for direct messages. User login topic serves as a trigger for creating users level topic setup for whenever a person logs in. Common post topics contains it serves as an in-memory store of all the recent posts for us to serve it up to the users. Community feed topic and user direct message topic. User community feed and user direct message topics are user level topics created while the user is logged in. The last piece of this is that we could use Kafka streams to also generate aggregations and analytics on all of this, store it in Cassandra, and have any kind of visualization tool like Superset, Grafana, Kibana to display the real-time analytics. We could probably also use matplotlib to directly put up an analysis streaming dashboard. But again, I would think that the visualization part of this would be mostly out of scope and for this project. I know I'm well over time. I hope this was in line with what you expect and that it was detailed enough. Thank you.